Wonderful. I'm really happy to say that our second speaker began her career in astrophysics. She subsequently became a UN champion of the Earth. And you know, I'll tell you, you may know this, but a handful of scientists spread across the world are really perceived as the globe's primary experts on climate change. We're now fortunate to be able to listen to one of them. Katharine Hayhoe is Paul Whitfield Horn Distinguished Professor at Texas Tech University and Chief Scientist of the Nature Conservancy. In 2014, she was listed as one of Time magazine's 100 most influential people. She's a tireless evangelist for the correct information on climate action. With her talk, The Most Important Climate Equation, Science plus Worry plus Action equals Hope, please join me in welcoming Katharine Hayhoe.
When I was young, we didn't have a TV. My parents were educators, and early on they read a book that said that television destroys children's brains. So instead, on Friday nights, my mother would go to the library and she would rent movies. And one of the movies that she would rent again and again was of a young blonde woman working with chimpanzees in a jungle. And so I grew up as a 3-year-old, as a 5-year-old, as an 8-year-old, with the idea that scientists are young women doing amazing things. And here I am today. It amazes me that I'm able to be here today with that woman who I was watching on that screen when I was a child. And I know that she has inspired you today. She has inspired many of us throughout our lifetime to dedicate our lives to understanding how we can make a difference. So what I wanted to speak with you today about is the most important equation. We scientists, we work with equations all the time. In fact, equations are often what we use to define our work. The equation I want to talk with you about today has 3 components. And the first component of this equation is science. I am an atmospheric scientist now. I study the science of our planet. And science can tell us a lot of information about what this conference is about, the future of our planet. I think of this as the head component. Science is about all of our data and our facts and our numbers and our observations and our models, everything that is in our heads. We often picture our planet like this, a blue planet seen from space. And we can model that planet using the most powerful supercomputers in the world. I work on a regular basis with what we call the primitive equations: conservation of energy, mass, momentum, hydrostatic equation. We put these into our models to reproduce the complex dynamics connecting the ocean, the atmosphere, the land surface, and the ice. But today, a more accurate way to look at our planet, I think, is not during the day, but rather at night. Because when you look at night, this is literally a photograph of our planet. And what do you see at night? You see the lights of human habitation. 8 billion people now live on this planet. And for 100 years, these lights have been powered by coal, by oil, and by natural gas. And so when I look at the planet, I don't look at the picture of the planet during the day. I don't look at the picture of the planet at night. I look at a picture taken by satellites to envision something that is invisible to our human eyes. I look at the level of carbon pollution in the atmosphere. And this is what it looks like seen through satellites. Because we know, and you will hear at a subsequent talk today, we know that as far back as we can go in the history of this planet, we have never seen climate changing this fast. It has been warmer before, it has been cooler before, but it has never changed this fast, and it has never changed because of human choices before. So it is no exaggeration to say that we are conducting an unprecedented experiment with the only home we have. So we use other equations to model this experiment. We use equations that connect population, technology, energy, economics to emissions of these heat-trapping gases that are building up in the atmosphere, wrapping an extra blanket around our planet, causing it to warm. We then use more equations to connect these emissions of heat-trapping gases to the temperature, and then we use a whole other set of equations to connect the change in temperature to the risks. What are the risks incurred by our choices and our behavior? So this leads to the second component of my equation. The first is science, the second is concern. Not all science engenders concern. We can study science and have no concern about it whatsoever. At the beginning of my career, I studied variable star dynamics. I had no concerns over what the science was telling me. But today, we have concerns over what the science of our planet is telling us. And I think of this as connecting our head, all of our data and information and facts, to our hearts. Why does it matter? That is what is so unique about the science of studying our planet today. When we can make this connection from our head to our heart, I often make it not through using the words global warming, but rather through using the words global weirding. Because wherever you live, anywhere around the planet, you have seen how the weather is getting weirder. I was standing in line to pick up my son some years ago from class, and the man behind me said, "Do you mind if I ask you a question?" And I said, "Well, sure, we're standing in line. I'm not going anywhere." So he said, "Do you feel as if the weather has gotten weirder?" And I thought about it, and I said, well, I know from the data that we've always had heat waves, but the heat wave season is coming earlier, it's ending later, and our heat waves are longer and stronger than they used to be. I know that we've always had wildfires, but the wildfires are burning greater area than they used to. I am from Canada, and we just had the largest wildfire season on record last year, and our wildfire season already began again this spring. In fact, over 100 wildfires went underground during the winter, and now they're coming back out. I live in Texas, and in January, Texas had its biggest wildfire ever. So we know that these wildfires are getting bigger. We know that our droughts are getting longer and stronger and more intense. We know that hurricanes, typhoons, and cyclones, they get their energy from warm ocean water. And remember, I mentioned that we are wrapping an extra blanket around the planet of heat-trapping gases, causing it to warm. Did you know that almost 90% of that energy is going into the ocean, where it is powering much stronger storms that are dumping much more water, and they're moving more slowly, and they are intensifying faster, especially as they get close to shore, which is just where you don't want them to do that. We know that atmospheric rivers are getting stronger, and we have a panel later this week talking about atmospheric rivers, rivers of water in the sky that when they reach the continent and they start to rise over the mountains, they dump torrential amounts of rain. And then we also know that our heavy rainfall is getting more frequent because warmer air holds more water vapor. So when a storm comes along, as it always does, there's more water vapor for the storm to pick up and dump than there was 50 or 100 years ago. So I turned to the man behind me and I said, yes, the weather is getting weirder. That's a very good way to put it. And since then, wherever I've gone, I was on a train from Prague to Vienna, and the man beside me asked me what I do, and that's always an interesting question when you ask a climate scientist what they do. I told him, and he said, do you feel like the weather's getting weirder? Wherever we are, something is happening, and people are concerned. Around the world, most people are worried. What you see here is 60% and over is pink or red. The gray countries were not surveyed. 60% or over is pink and red, and most countries are pink or red, except for some countries where people literally don't know if they'll be able to feed their family tomorrow or if their home will be safe tomorrow. So most people are worried, but the researchers asked a second question. They said, do you think climate change will affect you? What is this? This is what I think of as the head-to-heart gap. We still have not connected our heads to our hearts. We understand it's real, it's bad, it's us. We understand the ice sheets are melting, sea levels rising, the polar bears are endangered, but we haven't connected it to our lives. So that is why concern is the second part of the equation. We must connect our head to our heart. How do we do that? Well, a few years ago, I was speaking to a group of people in the middle of the United States, and they said, okay, I understand that this is bad, but how do I tell people about the polar bears here? And I said, well, unless you have polar bears here, and I've never seen them before, not in the middle of the US, you don't. That's not connecting the head to the heart. When I'm in Texas, where I live, I talk about cotton with Jack, who hasn't seen a regular harvest since 2005. I talk to people about their home insurance rates and how insurance is getting very expensive because of all the disasters that are happening, putting our homes at risk. This is my colleague Joellen. She's an oceanographer. She knows everything that you can imagine about how climate change is affecting the ocean, but what does she talk about? She talks about her children. She lives in Arizona, and it is so hot in the summer that she has to wake up her children before the sun comes up, because that is the only time they can play outside safely. That's connecting the head to the heart. We can talk to people about how pollution from burning coal and gas and oil kills millions of people every year. We can talk about how the food we eat is getting less nutritious the more carbon pollution we have in the atmosphere. We talk about how the water we drink is becoming more scarce and more polluted. Floods and droughts are both getting stronger. We can talk about how all of our buildings and roads and homes, all of our infrastructure was built for a planet that no longer exists. It was built for conditions 30 years ago, 50 years ago, 100 years ago. In this town, 500 years ago. Everything we've built is at risk. And we can also talk about the nature that surrounds us, the nature right here in this country, and the nature far off that is still relevant to our lives, because did you know more than half the oxygen we breathe comes from tiny phytoplankton and kelp in the ocean? Our lives depend on nature. Nature doesn't need us. We need it. And nature has seen warmer and cooler conditions before, but the rate of change that is happening is putting all of us living things at risk. Nature and humans. So to connect the head to the heart, we have to show people that to care about climate change, you don't have to be a scientist. You don't have to be an environmentalist. You don't have to be an activist. You only need to be a human. Are you a human? Do you live on planet Earth? Do you breathe the air? Do you drink the water? Do you eat the food? If your answer to any of those questions is yes, then you're the perfect person to care. Now, this is the second time I've spoken at Starmus. Last time I spoke, I had the honor of speaking right after Martin Rees, who is also speaking at this conference. And we both spoke right after Stephen Hawking gave one of his last talks. And as you know, he was a strong advocate for climate action. And so I was sitting right there in the front row, and I was nodding along as he was talking about climate change. And then he said something that maybe just sort of screeched to a halt. He said, and climate change is such a serious risk that this is why we must terraform Mars. I thought to myself, no, there is no way that we are going to terraform Mars and move any reasonable amount of people there before climate change overwhelms our civilization. If we don't fix climate change, we can't fix anything else. And if we don't figure out how to fix climate change, why would we think we'll do a good job with Mars? So afterwards, I was backstage with Martin. I said, do you mind if I ask you a question? And he said, sure. I don't do accents, so I'm not going to pretend that I'm going to speak like him. And I said, do you agree with what Stephen Hawking said about having to terraform Mars to escape from climate change? And he said, oh no. He said, fixing climate change is a dawdle in the park compared to terraforming Mars. And explore space all you want, but if we don't fix the problem we have right here, we're not going to be able to do anything else. Climate change is what stands between us and a better future. And if you're a human living on this planet, which so far every one of us is a human living on this planet, you're the perfect person to care. This head-to-heart connection, I'm not the first person to think of it. In fact, our previous speaker said this: only when our clever brain and our human heart work together in harmony can we achieve our full potential. Such wise words from Jane. Only when our head and our heart are connected can we move on to the third term in the equation. And the third term is action. But so often we try to jump right from head to hands without stopping at the heart. We try to skip the concern and go right from here's the data, now let's do something. But as humans, it goes through the heart. So we connect our head, why it matters, to our heart, why we care. Then we can bring in the hands what we can do about it. And when we look at the hands, I'm going to use a very American metaphor since I live in Texas. The whole idea of a silver bullet. There's no one magic solution that will fix it all. If you see a headline saying, this is the solution, beware. But there is a lot of little tiny pieces that when they add up, give us everything we need. What do we need to act? If you think of the atmosphere like a swimming pool, and the level of water in the swimming pool is like the level of heat-trapping gases in the atmosphere. Before the Industrial Revolution, we had just the right amount of water in the pool that our toes could just touch the ground. At the beginning of the Industrial Revolution, though, we stuck a giant hose in the swimming pool, and we've been turning the hose up every year. The first year of the pandemic, we turned it down 7%, and then we turned it right back up again. So what's the first thing we need to do? We need to turn off the hose. How? Well, there's many ways we can turn off the hose. The first way is efficiency. We waste more than half the energy we produce. The second way is through clean energy. We can work with reducing and eliminating deforestation, taking up carbon from the atmosphere, climate-smart agriculture, behavioral change so we don't need as much energy in the first place, and for the last few drops in the hose, we have very expensive and very energy-intensive technological solutions. There is no way to turn off the hose without A, B, C, D, and then the last few drops with technology. Our pool, though, has a drain. And much of that drain is nature. When we invest in nature, it takes up carbon from the atmosphere and it puts it back in ecosystems in the soil where we want it, instead of the atmosphere where we have too much. Carbon is not bad, it's the basis of life. We just have an imbalance. We have too much up here and not enough down here. Protecting ecosystems is number one. Old growth forests store so much carbon as well as being biodiversity havens. Restoring degraded ecosystems, coastal wetlands, grasslands, and more. Regenerating, that's where we talk about planting the trees, putting in new ecosystems. Climate-smart agriculture can take up carbon. And then for the last few drops down the drain, we have the expensive, energy-intensive technology like direct air capture. But there's one more thing we have to do. The level of water in the pool, it's so high now that for many people, their toes don't touch the ground. People are already suffering. And although climate change affects us all, it does not affect us all equally. The poorest and most vulnerable people in the world are the ones who are most impacted by climate change. And that is not fair. So building resilience, helping people learn how to swim, building resilience through all kinds of different ways, adapting our infrastructure, using technology, working with nature to help us adapt, greening our cities, providing flood areas around rivers, restoring coastal habitats, and helping people adapt socially to these changes that we're seeing. There's no one thing that will fix it all, but we have so many solutions to turn off the hose, make the drain bigger, and learn how to swim. And when it comes to these solutions, we truly have good news to share. Climate solutions give us air that is cleaner, water that is more abundant, protect us from these increasing disasters of global weirding. They improve our physical health and our mental health, give us energy that's more affordable, not less, reduce rather than growing our inequalities, creating food systems and ecosystems that are healthier. They give us a better world. This truly is good news. And so that's why the most important equation that I feel we need to know is this: science plus concern or worry, head to heart, plus action, heart to hands. That is the equation for hope.